everyone. This is a great one for you to pause and zip through these really, well, maybe not zip through them, some were kind of messy. Work through these real quick and then check back in and see if you got them right or not. So this one is all natural log mixed with other functions we already knew. No inverse trig on this one yet. The next one will have some inverse trig. Okay, so first one is in x squared times the natural log of x. So its derivative is going to be a product rule. So we'll take the second and we'll multiply by the derivative of the first. Be really clear that even if I drop those parentheses, which is legal, I can't multiply the 2x by that x. And then I need a plus the first times the derivative of the second. Derivative of natural log of x is 1 over x. So I do get to cancel a little bit, and I'm going to simplify and rewrite it nicely. I'm seeing a 2x times the natural log of x plus an x. Okay, the second one has a natural log mixed into a quotient rule. So p prime is going to be a quotient rule. We're going to want the bottom, e to the t plus 1, multiplied by the derivative of the top, which is 1 over t, and then minus the top, natural log of t, multiplied by the derivative of the bottom, which is e to the t plus 0, and that's all over, e to the t plus 1 squared. So the one thing that I see that I would really like to deal with here is no fractions in fractions. So I'm going to multiply top and bottom by t. You got to make sure you distribute that in. So in this first one, so this is one big term right here. It's hooked together by multiplication, so it's a single term, and the same thing with this. The t's cancel, so I'm left with the e to the t plus 1. And then I have a minus t, natural log t times e to the t. You can keep that in whatever order you want. I kind of like t, e to the t, natural log t. And then that's going to be divided by the e to the t plus 1 squared, and that has to get multiplied by a t as well. So that would be my final answer. Okay, s of y is the natural log of the cosine of y plus 2. So this is, make sure you're really clear on the notation. Natural log is a function. Some people think this is times, and it's not. It's natural log of. So natural log of stuff. The derivative of natural log of stuff is 1 over stuff. And then the chain rule says you have to multiply by the derivative of stuff. So derivative of cosine y is the opposite of sine y. The derivative of 2 is 0. And then my simplification would be just to make it a single fraction. So I don't know about you, but I think the natural log is actually rather nice to deal with. It just makes a fraction out of some stuff. We don't get a lot of weird powers. They tend to look pretty nice when we're done. Okay, now I have the tangent of the natural log of x. Again, it needs to be really clear to you when we have of versus times. Okay, so this is tangent of stuff. Its derivative will be secant squared stuff. Once we've dealt with the tangent, we're left with the natural log of x, which means we're going to be multiplying this whole thing, and this really is multiply because it's a chain rule, by 1 over x. So c prime of x is equal to secant squared natural log x all divided by x. If you'd like, you could also make that 1 over x times cosine squared of the natural log of x. So it's up to you if you're using 1 over cosine squared or secant squared when you have tangents. Okay, last one, natural log of the natural log of z. So derivative of natural log of stuff is 1 over stuff. Alright, so now we've dealt with the first natural log, but we've got another one. The natural log of z has derivative 1 over z. So that's what we end up with, and we can just mush that into a single fraction, and I'm going to make it a z natural log z. You don't have to put the z out in front. The reason I like to do that is it makes it really clear that it's not part of the log, kind of avoids that temptation of making it natural log z squared, which would not be right. Alright, thanks for watching.